Do you have any estimation? So don't right now forget about the cost. How much other source of energy you should spend to create 1 kilojoule of? It should be smaller than.
Of course, these estimations exist, right? I mean, the companies do these estimations. So it's a question of the economy of scale, right? When you scale up the production, how much will that bring down the cost?
I'm not talking about the cost, just the energy, because you should burn fossil fuel or use hydro energy to so because I'm not sure, so it should be less than 1, so it should be higher. The amount of energy you put to build the fuel cell, you should get more energy because you want to make the fuel cell to reduce the use of fossil fuel. So
no, I don't have an estimation.
Another question, I heard about and I read about the zinc fuel cell, and they use it in the automotive application as well. Do you know what's the benefit and the problem of this compared to? No?
I mean, I have heard about that as well. So the zinc is actually an electrode that is being used up, right? So there's a flow of the metal.
Their charges, like a hydrogen, they have an infrastructure to go to the station and they put a small amount of in the sphere shape zinc.
I mean, really nowadays there's not a clear distinction anymore between batteries and fuel cells. So it's more or less, I mean, there are so many different types of fuel cells and different types of batteries. It's more or less like the boundary has vanished between them. So, well, I don't know about this particular.
Thanks.
Yeah. So I have two things. So one, both are comments essentially. This is essentially an energy storage solution. It's not an energy production solution. Right? This is the energy. This is elimination of the combustion engine and the Carnot cycle efficiency, which is replaced by a cycle with higher efficiency.
Exactly.
And it doesn't address the question of fuel production.
Exactly. It's a question of the fuel that you put in.
Yeah. So you still need the fuels.
If you use gasoline, the only advantage that you get is the efficiency gain. And efficiencies are, let's say, 50% better. Or, yeah, let's say 50% better than the efficiencies of best combustion engines nowadays. So there's a certain gain, yes. On the other hand, well, these cells operate best if supplied with neat hydrogen.
Yeah.
So
where do you take it from?
Right. So it's a chicken and egg problem, right? So the hydrogen infrastructure has to be built, and in principle, in order to make this a true so-called sustainable solution, the hydrogen has to come from solar energy. And then it would be no pollution, emission-free, and well, you've seen that comparison of photovoltaic hydrogen production versus fuel production from biofuels. So photovoltaics is much more efficient, about a factor 12 actually, at least based on that simple estimate. So that would be the true advantage.
I mean, I think the advantage of this is you don't have to go solar, right? So of course, what I'd like you to say is that you can go nuclear, and then it's
you don't have to go solar, right? You don't have to go nuclear, but it's living on a finite planet, right?
Yeah.
So
where you convert mass to energy.
Nuclear could be like an intermittent solution. I don't know how long it would actually go. And also, I mean, in all of this, it will probably not be possible to maintain that kind of individual mobility infrastructure that we have, because it's simply a burden that cannot be carried forward into the future, right? It uses way too much energy, so there need to be new different concepts. And that's an issue of social political stewardship, I believe.
So the other thing, I think that on the temperature rise from the entropy production, I think that one thing which saves us is that the black body radiation increases like T to the 4.
That's right.
And that's what, right? That's what takes care of it, essentially. You radiate more when you increase the temperature.
Yeah.
I just have like so the entropy or the temperature entropy balance, energy balance. At some point, like the whole world was really warm, and so it was supplying that same energy difference. So why is this temperature rise bad, and why is that temperature rise okay? So essentially, we're using up all that energy that took a long time to store up. We're using it up very quickly.
The point is the time scale, right?
Yeah.
I think that's a key point. As far as I understand, it's a time scale.
Yeah.
There's this cycle of about 600,000 years. Has a certain name of a Russian scientist, I believe, of heating or this temperature cycle, which is well documented actually, much better than one would believe. And that actually predicts that we are significantly behind, let's say, cooling phase, right? So it could significantly behind means on the scale of 10,000 years. So it could be in the next 5,000 or 10,000 or 50,000 years, right? Yeah. So it would still preserve that cycle. But I mean, these changes now are occurring on the time scale of 10 years, 100 years, right? So I think it's a question of how much time do we have to adapt. Not like technology-wise, right? But in terms of organisms. Organisms need a long time scale to adapt to changing conditions, right? So this may just be too fast.
I'm sorry I have to interrupt, but these guys need to move, so we can go outside and continue to talk.